All right, pre-calc. This is semester 2, Apex, chapter 1.2 and 1.3. I kind of did them together because they're pretty similar chapters. So, you know, if you want to stop and take the quiz in the middle, that's fine. But let's go on ahead and work through. A lot of this is review. So an angle is the union of two rays having a common endpoint. So if we want to name this angle, there's 3 different ways we can name it. So I'm not going to use the blank there. We can name it angle MNP, angle M, or we could just name it angle N because there's no other angle coming off of that vertex. So review, once again, a lot of this is review. There's a couple of new things added in. An acute angle measures more than 0 degrees, but less than 90 degrees. An obtuse angle, in the past, we've always just said, hey, it's more than 90 degrees, but really it's more than 90 degrees and less than 180 degrees. Okay, this is a new term for most of you, a reflex angle. It measures more than 180, but less than 360. And then a 0 angle, I know this is going to be difficult, is 0 degrees, and a straight angle is 180 degrees. So once again, you guys have seen most of that, and most of this stuff is just a review so that we can really dig into the trigonometry portion. So you guys had to do this a lot on your Algebra 2 project last year, if you were here anyways. So 1 degree equals 60 minutes, and 1 minute equals 60 seconds. So we're going to go on ahead and we're going to convert each of these from degrees to degrees, minutes, and seconds. So all we're going to look at here is the decimal. So we're going to take that decimal and we're going to multiply by 60. Okay, that's going to give us a whole number with a decimal. Okay. So my 51 degrees stays the same. This whole number portion becomes my minutes. And now I have to take this 0.8 times 60 to get my seconds. And that becomes 48, 8.48. So that's 48 seconds. So we're going to do the same thing. We're going to take this 0.28 times 60. And 0.28 times 60 is 16.8. So we're going to keep the whole number portion of it. So 95 degrees, 16 minutes. And then this 0.8 is going to be multiplied by 60. And that gives me my 48, my 0.48, which is my minutes. So that's my final answer. 6.74. Okay. Let's go on ahead and let's use our calculators to do this one. So I'm just going to type in 6.74. On your calculators, there's an angle button. So it's blue, so I'm going to hit the blue key, the second key, angle. And you'll notice down here it says it has an arrow and it says 2 DMS. Hit that and hit enter. Oh, look, it did it for me. So 6 degrees, 44 minutes, and 24 seconds. Okay. I can do it by hand. I can use my calculator. Okay. As long as you guys know how to do it, I'm happy. Okay. So now we're going to go backwards. We're going to convert each of the following to decimal degree notation. So here we were multiplying by 60 for each time. So here we're going to divide by 60. So we're going to start with the seconds and we're going to divide by 60. Okay. So 12 divided by 60 gives me 0.2. So next I have, okay, so that gives us 0.2. So now I'm going to take this 25, okay, and I'm going to bring it down and my 0.2 down. So this is going to become 25.2, and I'm going to divide that by 60. So when I divide 25.2 by 60, I get 0.42. So my answer then is going to be 11.42 degrees. So we're going to do the same thing for this next one. We're going to take 36 and divide it by 60. There we get 0.6. So we bring the 15 down. That 0.6. That's not a 6, that was a 5. Okay, and then we're going to divide that by 60. And that gives us 0.26. So our answer then is 42.26 degrees. But yes, if you recall, you can use your calculators to do this. Okay? It's going to be a little bit different. So let's see if I can move this over so we can see both. All right, so we're going to enter our 186, but we have to enter those degrees, minutes, and seconds symbols. So to get to our degrees symbol, we're going to go into that angle menu again. So second, apps gives us our angle menu. Oh, look, there's the degree symbol, and you'll notice there's also the minute symbol. Okay, so 186 degrees, 8 minutes. So I'm going to go back into that angles menu and click on my minutes. Okay, and now I have 24 seconds. Well, my seconds is actually down here on my plus sign, okay, and it's green. So I'm going to hit that alpha, okay, and then I'm going to hit the plus sign, okay, and that gives me my minutes. And then I don't have to go into the menu or anything. I just have to hit enter. And right there, it gives me my answer. So 186.14 degrees. All right, so let's take a look at changing degrees to radians and radians to degrees. So the formula here, hopefully on your paper, you can see it better. So to multiply, to go from degrees to radians, you multiply by pi over 180. To go from radians to degrees, we're going to multiply by 180 over pi. Now, I don't memorize these formulas. Okay? I just remember if I have to get rid of the pi symbol or if I have to get the pi symbol in my answer. So pi over 6, it's already in radians because it's got that pi symbol in it, which means I have to get rid of the pi symbol and it's going to have to cancel. So it goes in the denominator. That means 180 goes in the numerator. So now 180 divided by 6 is 30. So my answer is 30 degrees. The next one is 120 degrees. I have to get a pi symbol in there, so it's going to be on top. And I have to get my number to get smaller. So 180 is on the bottom. Okay? So now 120 and 180 are both divisible by 60. And that gives me 2 times pi over 3. Okay? 5 pi over 4. I need to get rid of my pi symbol. So it's in the denominator. And then my 4 and 180. 180 is divided by 4, and that gives me 45. So 5 times 45 is 225 degrees. Okay. I'm going through this pretty quick, but once again, this should all be review. Okay. All right, this next part, it is review, but it's actually review from geometry, from arc length. Okay. So here we have a circle. So we have a circle with a radius of r and a central angle of theta. We actually want to find this arc length. And remember, in geometry, you learned minor arc length, okay, is less than 180 degrees, or a major arc length, okay, is greater than. So the formula for arc length is r times, that's an r times theta, where theta is the measure of the central angle in radians. Okay, that's important. It needs to be in radians. So if we plug in 1 for r, we're going to get an arc length of theta for our unit circle. And that's what we're going to start building here in just a minute. It's our unit circle. But let's look at if we have r of 12 and we have theta equal to pi over 3. Okay, that gives me 12 pi over 3, which is really just 4 pi. So this formula right here, okay, you're going to want to know that that's the length of this arc. Okay? And when we start doing our unit circle, we're not going to be dealing with arc length. We're going to be dealing with our x and y values. Right, so here's a problem, common problem using arc length. So it says, suppose two radii of a circle determine a 45-degree angle. So I have a circle here, and I have two radii that create a 45-degree central angle. The length of both radii is 64 yards. What is the arc length formed by the two radii in yards? Well, so that's r times theta. Remember that r has to be in radians. Well, 45 is degrees. I have to change that to radians, so I need to get my pi symbol. So I'm going to multiply by pi over 180. And 45 times pi over 180 is going to be pi over 4. So now I'm going to do pi over 4 times my theta. Oh, sorry, that was my theta. So times my radius, which is 64. So that's going to give me 16 pi. Hey, we are in pre-calculus, we want the most exact answer. Okay, so this would be the exact answer, but it tells us they want it in decimal places to 2 decimals. So I'm not going to multiply by 3.14. I'm going to use my pi key here on my calculator, 16 times pi there. And when I do that, I get 50.27 yards. So now we're going to move on to 1.3, and this is actually your unit circle. Okay? So let's start talking about how our unit circle is derived and how it happens. I don't remember who derived the unit circle, but it comes from the Pythagorean theorem. Okay? So, and it comes from the Pythagorean theorem and our special right triangles, which also come from the Pythagorean theorem. So our unit circle is a circle with a radius of 1. Okay, so here's our circle with a radius of 1. Okay, so we have these points on it, okay, but we need to be able to find points anywhere in that circle. So if we look at our circle, and this is our theta, our central angle, okay, this is going to be some y value, and this is going to be some x value. So now it says assume x and y are not 0, and we need to find the 6 trig functions for theta in terms of x, y, and 1. So this is my 1 because it's my unit circle. All right, so I'm going to find sine of theta. Sine of theta is opposite over hypotenuse. So it's going to be y over 1, which is just y. Cosine of theta, adjacent over 1, x over 1, which is just x. And then we have our tangent of theta, which is opposite over adjacent. So that's y over x. Okay, so those are our first 3. Now for our other 3, we're just going to flip them. So cosecant of theta, well, this was y over 1, so this is 1 over y. Secant of theta is 1 over x. And cotangent of theta is x over y. So what this tells us, okay, is that sine is y and cosine is x. So any point on our unit circle is going to be able to be found, okay, because we know a cosine of theta and we know a sine of theta. So that's our x and that's our y. Okay, but now we have to figure out how we actually find the values in this unit circle. Okay, so a 30, 60, 90 triangle. Okay. So here's my 30, 60, 90. So remember that this is m, okay, this is 2m, and this is m times the square roots of 3 from the formula that we talked about yesterday and you learned in geometry and you saw again in algebra 2. Okay. So now, if my radius is 1, I need to figure out what these two sides are. So if my radius is 1, okay, it's going to be m equals 1/2. Okay, so that side length is 1/2. Okay. m times the square root of 3 is 1/2 times the square root of 3 over 1, which is square roots of 3 over 2. Okay, so these are the big numbers we need to remember. So let's look at the 45, 45, 90 triangle now. Okay, so our 45, 45, 90 triangle, this is m times the square roots of 2. Okay, and each of these side lengths are m. So we need to figure out what our m values are. Okay. So let's see, our m value is m times the square root of 2 equals 1, divide by the square root of 2, right? And I get m equals 1 over the square root of 2, but remember, we don't ever leave a radical in the denominator. So I'm going to rationalize that denominator, and I get square roots of 2 over 2. So this side length is square roots of 2 over 2. So now, if we can find the sine and cosine of 30 degrees, 60 degrees, and 45 degrees, we can put our entire unit circle together. Okay? So I gave you guys 2 unit circles, a big one and a little one. The little one was kind of for a chicken scratch so that we can develop it. And the big one is for you to actually write the answers. Okay, so let's take a look at this first portion. So here, I'm going to take and I'm going to figure out some angles. So this is 0 degrees. This is where we start. If we go all the way to a straight line, that's 180 degrees. And then we have our right angle, which is 90 degrees. Same thing down here, 180 plus another 90 is 200 and, oh geez, 250 degrees. 270. I thought it was 270, but I couldn't remember. All right. And then here we're back up to 360 degrees. So we already know what these coordinates are because we know our x's and y's. Remember that this is a unit circle, so it's a length of 1. So our x value here is 1. Our y value is 0. Our x value here is 0. That's 1. Okay, now here our x value is -1. And 0 is our y value. And here our x value is 0 and our y value is -1. So the very first thing I'm going to do is I'm going to say that I'm inviting 2 friends over to my house, or 1 friend over to my house, and we're going to split some pie. Okay? So if this from 0 to 180 is 1 pi, okay, I need to split that in half. And how many pieces of pie do I have? Well, now I have pi divided by 2. So that's my 90-degree angle. But, you know, I really like having friends over. So now I'm going to invite a couple more friends over. And I'm going to break this into 3 pieces of pie. So I'm going to have a piece, and a piece. Okay? So there's 3 pieces there. Okay? So this is 1 piece, this is 1 piece, and this is 1 piece. All right? So here, if I split 180 divided by 3, okay, this is going to be 60 degrees. Add another 60 degrees gives me 120 degrees. And if I add another 60 degrees, I get to my 180. Okay, now we got to figure out our pi's, our radians, right? So we could either multiply by pi over 180, or how many pieces of pie did I split this into? Into 3, so that's pi over 3. How many slices of pie is this? Oh, this is 2 slices of pie out of my 3. And then I have my 3 slices of pie out of 3, which is just 1 whole pie. Okay, so that's how I like to think about it, because then it kind of helps you figure out your pi values. Okay. Next, let's say, well, even more friends wanted to come. So now I'm going to break this into 4 pieces of pie. So there's a piece, there's a piece, Okay, so I have one piece here, 2 pieces, 3 pieces, 4 pieces. Okay, so this is 1 pi. Oh, this is 1 pi out of 4. I wrote that on the wrong blank. This is 2 pi's out of 4, which is 1/2, pi over 2. And here I'm going to have 3 pieces out of 4. And here I'm going to have 4 pieces out of 4, which is 1 total. Same with our degrees. 180 divided by 4 is 45. So this is 45. Add another 45 and we get to 90. Add another 45 and we get to 135. And add another 45 and we get to 180. Okay, so then the last one, I'm going to break it into 6 pieces. So that's going to be pi over 6. Okay. Then we're going to have 2 pi over 6, 3 pi over 6, 4 pi over 6, 5 pi over 6. That's 30 degrees, 180 divided by 30. So that's 30, 60, 90, 120, 150, and 180. All right, so that's just building the degrees and the radians. But now we need to build those sines and cosines, and that's where we're going to come back to our circles. Okay. So our pi over 6. Okay. Well, that's 30 degrees. So my sine value, remember from way up here, my sine value is my y value. Okay. So pi over 3, okay, sorry, not pi over 3. My sine value is going to be opposite over hypotenuse. So that's 1/2 over 1. So that's going to be 1/2. My cosine value is my x value. So my cosine of 30 degrees is square root of 3 over 2 over 1. Let's go on ahead and do our pi over 4. So that's 45 degrees. So we're going to use this one. So my sine is my y. So that's going to be square root of 2 over 2 over 1. And my x is going to be the same. All right, now we're going to do our 60 degrees. So now we're looking at our 60 degrees and we need our sine, which is opposite over hypotenuse. So sine is square root of 3 over 2. And then my cosine is 1/2 over 1. Okay, so that's going to be 1/2. Okay. So these are going to be the exact same, okay, but they're mirror images of each other. Okay, so if this is 1/2 root 3 over 2, then this is 1/2 root 3 over 2. And this is where you can kind of start filling in your big unit circle. Okay? And you don't have to fill it in, it's up to you. You guys will have some timed opportunities to fill it in where you're going to have to fill it in within 2 minutes. Okay, so we will be timing, we will be having, you know, races to get it filled in. So make sure that you know how. So this is root 2 over 2, root 2 over 2. This is root 3 over 2 and 1/2. But okay, you also have to remember that this unit circle is on an XY coordinate. So our coordinates here are a plus plus. Our coordinates here are a negative x and a positive y. Oops, positive y. Here it's a negative x and a negative y. And here it's a positive x and a negative y. So we got to make sure those signs are right. So all of these x values are negative. Here they're both negative. And once again, these are mirror images. So this one goes with this one. So square roots of 3 over 2, 1/2, root 2 over 2, root 2 over 2, 1/2, root 3 over 2. Okay, mirror images again. So root 3 over 2 and 1/2, and the y is the negative here. Root 2 over 2, root 2 over 2. And then here mirror image is going to be 1/2 and root 3 over 2. And you also notice that these two are always flipped. Okay. Oh, couldn't even see that. Okay, so notice that these two are always flipped. Okay, our x's and our y's. Okay. All right, now we just have to finish with our degrees and our pi. So now we go from, so here we started out with pi. So now we'll just go to the pi over 6's. So this is 6 pi over 6. So now we have 7 pi over 6, 8 pi over 6, which reduces, okay, so 8 pi over 6 reduces to 4 pi over 3. Okay. And then we have, let's see, 9 pi over 6, which reduces to 3 pi over 2, 10 pi over 6, which reduces to 5, let's see, 8, 9, 10, 4, 5 pi over 3. Okay, so here these are pi over 3's. Okay, and however, you know, whatever method you do that helps you do this the fastest, okay, is the way you want to do it. Okay, and then here we have 11 pi over 6. So you'll notice that our pi over 6's are always the closest to our x-axis here. The pi over 3's are the furthest away. Okay, and then we have our pi over 4's. So 4 pi over 4, 5 pi over 4, 6 pi over 4, 7 pi over 4. Oh, I put that in the degrees. And then 8 pi over 4, which is 2 pi. And then our degrees, so here from 180, we have to add 30. So that's going to be 210. Then we add 15, 225. Then we add 15, which is 240. Add 30 is 270. Add 30, which is 300, 315, 330, and then 360. So make sure you know the unit circle, make sure that you can develop it and that you understand why, because this is really going to be important when we start graphing these functions and as we use them to do other things. Okay? We're going to be doing lots of things with the unit circle, okay? Lots more than we did in Algebra 2. So let's take a look at, you know, if you want to find a value without using the unit circle, you can also use your hand trick. Okay? So these are our 4 quadrants of our XY coordinate plane. Okay? So quadrant 1, everything's positive. So, all. Okay. Quadrant 2, students. So S, that means the sign is positive. Okay, take. T, that means tangent is positive. And calculus. C means cosine is positive. So that's just a trick to help you remember what is positive in each quadrant, okay? You can also just know that your X's and Y's, okay? But sometimes as we start working on these problems a little bit more, and we're not using just the unit circle or just the pi over 3, pi over 4, pi over 6 values, this is going to come in handy. Okay, your other trick is your hand trick. So remember that it's always going to be either the number above what you put down or the number below what you put down. Okay, so if you take your left hand, this is 0 degrees. This right here is your pi over 6 or your 30 degrees. This is your pi over 4, your 45 degrees, your pi over 3, or your 60 degrees, and this is your 90 degrees or your pi over 2 finger. Okay? So all we're looking at here is the first quadrant, because if we know the first quadrant, then we're going to be able to know the rest of this. All right, so for the first quadrant, we're going to use our finger trick, okay? And if we want to find, you know, pi over 3 is 60 degrees, so we're going to put down that third finger or the fourth finger, or pi over 3 finger. So cosine is always the number above divided by 2, and it's the square root of the number above divided by 2. And sine is the square root of the number below divided by 2. So this cosine would be square root of 1 over 2, and sine would be square root of 3 over 2. And those of you that have had me before know that, just a reminder, I like to remember that sine is centers, and they're going to go down below. Okay. not religious or anything like that, you know, not meant to be. It's just something meant to be to remind you. So just keep that in mind, find a way to remember it, okay? That's my way. You can also find tangent. So tangent, okay, of 60 degrees. If I put my finger down, I flip my hand over, okay? And then I'm going to do the square root of the number on top, which is 3, over the square root of the number on bottom. So there I would get the square root of 3 over the square root of 1. So my tangent at 60 degrees is just the square root of 3. All right, so we have a little bit of rotation vocabulary to talk about, and then we will be done. This isn't going to take too much longer. So a couple of things. We have standard position. Standard position is where the vertex is at the origin, and one ray of the angle is at the positive, is on the positive, I guess let's see, vertex is at the origin. One ray is on the x-axis, that's right, in the positive, okay? And then one ray is in first quadrant. Okay, so let's draw a picture. I don't know why I'm still using brown. All right, so this right here would be my ray that's on my x-axis, and this would be my ending ray. So this would be a standard position angle. Right, so here I have my initial side. Okay, so my initial side is going to be the ray that's on the x-axis. So this would be my initial side. If I had another angle that went like this, okay, this would be my initial side. It's the one that's on the x-axis. Terminal side is where my angle stops. So this would be a terminal ray or terminal side. If this angle started here and went all the way to there, then this could be my terminal side. So it's whichever ray the angle ends on. And then we have rotation. Positive rotation is counterclockwise, just like our quadrants go. So if I'm going this way, I'm going to get a positive angle degrees. Okay. And then negative rotation is clockwise. So if I'm going this way, I'm going to get some negative, so negative angle degrees. And we will be using both. We will be going clockwise and counterclockwise. So coterminal angles, once again, you guys have seen this, so I'm going kind of quick through it. So coterminal angles share the terminal or the ending side when they're in standard position. Okay? So in other words, if I have an angle, it's 40 degrees, meaning it starts here on the x-axis and it goes up to 40 degrees. And that's my 40-degree angle. Coterminal angles, I can go around the circle. So I can start at my 40 degrees and go around and end back at that terminal side. So what I did there is I added 360 degrees. Okay. So an angle measure that is coterminal would be 400 degrees. Same thing for my negative. Okay. For my negative, I would start at that angle, terminal side, and go backwards 360 degrees. So that would be 40 minus 360, which would be negative 320 degrees. Okay. Sometimes you'll have to go counterclockwise or clockwise several times, right? Because if I started at 780 degrees, it would take me several times going backwards to get a negative coterminal degrees. So it doesn't mean just go backwards once. It means I want an actual positive degree value and an actual negative degree value. Okay, so same thing here. So for 88 degrees, I could add 360 and go around the circle. Okay, and that would give me, I don't know, what would it give me? 448 degrees. And I could subtract 360 degrees. And that would give me negative 272 degrees. So those would be two of my coterminal angles. There's lots of choices. Those are just the two I chose. All right, last two little sections here. Okay, so a reference angle, we're going to be dealing with these a whole bunch. So a reference angle is the positive acute angle formed by the terminal side and the x-axis. So here it says theta is 150 degrees. So 150 degrees is about right here. Okay, so that's 150 degrees. Okay, but my reference angle comes from here to here. Okay, so that's 30 degrees. Okay, and the reason I do that is because I know that if I were to use my hand trick, 30 degrees, right, I could easily find my sine or cosine that goes here. My sine is 1 over the square roots of 2, and my cosine is 3 over the square roots of 2. Okay, so I know that my coordinate there, my sine and cosine, okay, would be square roots of 3 over 2, negative, because my x is negative, and 1/2. Okay, so we're going to be using unit circles quite a bit, and we're going to be using reference angles to find these measures or these values. So here, this is negative 130 degrees. So we're going to start here, and we're going to go backwards 130 degrees. So this is negative 130 degrees. Okay. But to find our reference angle, remember it has to be acute. So we're going to start at this x-axis and go to there. So this would be negative 180 degrees. Okay. So our reference angle would be 50 degrees. Okay. It's a positive acute angle. All right, and the last step is the Pythagorean theorem in the unit circle. So here's our unit circle. Okay, here's our x, here's our y, and here is our 1. Okay. So Pythagorean theorem we know is a squared plus b squared equals c squared. Okay. Where these are the legs and this is the hypotenuse. So now we're going to write it in terms of sine and cosine. So remember that our y value is our sine, and our x value is our cosine, okay, and our 1 is our radius. Okay. So now we can rewrite it using our sine squared theta plus cosine squared theta equals 1. So that's just the Pythagorean theorem, okay? When there's a radius of 1 in a unit circle. Okay. It's finding the triangle. So really what we did is we found this height, and we found this length, and we found the exact point here where that is. Okay. So you need to memorize all 3 of these Pythagorean identities. Okay, so these are Pythagorean trig identities, that one, and that one. So what I would do is put this piece on the front of a note card, and I handed out note cards if you were in class, okay, and this piece on the back, put this piece on the front, this piece on the back, put this piece on the front, and put the one on the back. Okay, memorize them. Don't forget them. And I will see you guys all in class tomorrow. Have a great day.